Hello. This time we are going to focus on articles 131 up to 137. These articles all focus on the properties of the tritangent radii. So we have three x circles and one in circle. So we are going to focus on the 3x radii and one in radii, okay? So the very first one is that of this theorem. The inradius of a triangle is equal to the area divided by half the perimeter. Or we could say that the area is equal to the half the perimeter times r. In our textbook, P is the notation for the semiperimeter. P is equal to 1/2 A plus B plus C, where A plus B plus C is actually the perimeter of the triangle, okay? So, in this triangle ABC, okay, I could divide this into three triangles, and here are the three triangles. And let us show the three, and that's what it is. So the orange triangle, the yellow triangle, and the green triangle. So the area of the big triangle ABC is equal to the area of the orange one plus the area of the green one plus the area of the yellow one. Area of triangle AIB, area of triangle BIC, plus the area of triangle BIC and then AIC. But if we focus on the area of the orange one, the base here is the green one first, okay? The area of the green one is 1/2 base, which is A, times the altitude, which is R. So 1/2 RA. And then if we focus on the yellow triangle, it's 1/2 B times R. And finally, 1/2 CR. And that's what you've got here. And we can factor it out. And that's 1/2 R, A plus B plus C. And as I have said, A plus B plus C is the perimeter, and therefore half of it is the semi-perimeter. And in that case, solving for R, I will have R is equal to S over P, which is what the theorem is all about. However, I can extend this to x circles, x radii, x radius, etc., etc. So let's focus on one of them, okay? So let's consider, okay, this one, okay? And then let's focus on extend the lines. And then let's extend the external bisectors. And then we have the three excenters. So let's focus on this. I do not need this one. So I will hide this as well as this. I will just hide this portion. And I will hide this portion also. That's good enough. Okay. So here are the things that we've got here. So in this particular situation, we have the area of the triangle first. So area of triangle ABC, I will extend it because I want to make use of I sub B. So in that case, there are three circles in here, but right now I only color two triangles, the pink one and the blue one. But I want to focus on the area of the triangle ABC, so that is just this triangle here. So the area of triangle ABC will be the sum of the pink triangle plus the blue triangle, and therefore I need to subtract the green triangle right now. Now that makes it clear, okay? So the area of triangle ABC is equal to the area of triangle ABI sub B, and that's the pink one, plus the area of the blue one, which is area of triangle B, C, I sub B. And finally, I need to subtract this extra one that I've got, which is triangle A, C, I sub B. And if I do that, you will notice that the area of the pink triangle is equal to the altitude is now R sub B. And the base is equal to C. So that is 1/2 R sub B times C. The area of the blue triangle, the altitude will be R sub B, but its base is A. And finally, I will now make use of the base B. And in this case, the base is B, and the altitude is R sub B. And that's why we have this triangle. The base here is C, the base here is A, and the base here is B. Okay? And if I factor it, simple algebra will tell us that we have okay, 1/2 R sub B, A plus C minus B. Okay, I want something, and that's why I want to introduce P, so I can do that by adding B and subtracting B. So that's actually 2B here. So A plus B plus C minus B is the same thing as this. So with that, I can now get this one first. And then this one now is 2B divided by 2 is just B. That's why R sub B times B. And therefore, it's now this one, 1/2 A plus B plus C is the semiperimeter B times R sub B minus B R sub B. Factoring further, we have R sub B is equal to P times A times R sub B. Hence, from this result, I have R sub B is equal to the area divided by P minus B. Similarly, R sub A is equal to S over P minus A, and R sub C is equal to S divided by P minus C. So, that is the second theorem. The x-radius of a triangle is equal to the area of a triangle divided by the difference between half the perimeter and the side of the triangle relative to the x-radius considered. That's exactly what I just mentioned. Or, computing for S is equal to R sub B times P minus B. That's this one. And area also can be expressed as the product of R sub A times P minus A. And finally, S is equal to R sub C times P minus C. As a corollary to this, any of these two, if I find the product of all 4 radii, R sub A times R sub B times R sub B times R sub C, then we have, okay, S over P is R sub A is equal to this, R sub B is equal to this, and R sub C is equal to this one. So multiplying all 4 of them will end up with S to the 4th times P minus A, P minus B, times P minus C in the denominator. However, we need to go back to our elementary geometry class that says that the Heron's formula for the area of a triangle S is equal to the square root of P times P minus A, P minus B, P minus C. Or if we square both sides, S squared is equal to this expression. And this expression, you'll notice, is exactly this one in the denominator. So I can replace this by S squared. So the product of the 4 tritangent radii will just be equal to S squared. So beautiful. Okay. And the next corollary, the reciprocal of the inradius is equal to the sum of the reciprocals of the 3 x radii of the triangle. Okay, we can just add the 3 x radii. And where is our formula? Here is our formula, okay? So the reciprocal of r sub b is p minus b over s. Reciprocal of r sub a is p minus a over s. And reciprocal of r sub c is p minus c divided by s. So that's this added together. Now that becomes, denominator becomes s, numerator becomes 3p, and then minus a, minus b, minus c, and that's why we have this one. I need to do simple algebra here. Well, a plus b, a minus b minus c will be equal to minus a minus b minus c if I can multiply numerator and denominator by 2 over 2. And therefore, this one is equal to p. So this is just 3p minus 2p. And we have this. Hence, the sum of the 3x radii is equal to p over s, or finally, it's 1 over r. And here's the formula. And we have two more activity, and this one is a theorem and one is a corollary, and this is just very easy. The reciprocals of the inradius of a triangle is equal to the sum of the reciprocals of the altitudes of a triangle. So this time I had to introduce the three altitudes of a triangle. So it could be, the altitudes could be outside or inside. So let's focus on just this situation, okay? So here it is. Now, the area of triangle ABC is the same thing as the area of is equal to the formula 1/2 a times h sub a. A, the base, times h sub a, and multiplied by 1/2. Or I can use b, so that is the base is b, the altitude is h sub b, and multiplied by 1/2, and 1/2 c, h sub c. So because of this, we know that s is equal to p times r. Multiply both sides by 2, 2s is equal to 2pr. And therefore, this particular formula from here is equal to a h sub a. I need to get rid of the 2 here. Or b h sub b, which is equal to c h sub c. Now, from here, it seems like what I need to do here is 2pr can be expressed as 2p divided by 1 over r. A times h sub a can be expressed as a divided by 1 over h sub a, and similarly that's true for b and c. Okay? Now, let us recall a property of proportions in elementary geometry, that if a over b is equal to c over d is equal to c e over f, we can add all numerators together, a plus c plus e, and add all denominators together, b plus d plus f. The sum is the same thing as a over b, or any of these fractions. Hence, these fractions, if I add the numerators, a plus b plus c, and I add the denominators here, the sum, the resulting fraction will just be equal to 2p over 1 over r, and that's it. However, let's recall that the semiperimeter, or 2p, is equal to a plus b plus c. Hence, the numerator can be cancelled, and eventually we will end up with the actual theorem. The reciprocal of the inradius is equal to the sum of the reciprocals of the altitudes of the triangle. And last but not the least is a corollary, which is a consequence of this theorem and the previous corollary. Okay? So, the sum of the reciprocals of the x radii of the triangle is equal to the sum of the reciprocals of the altitude. So in the previous page, we had this. 1 over r is equal to 1 over r sub a plus 1 over r sub b plus 1 over r sub c. Hence, this particular theorem. And just this one, we also proved that 1 over r is equal to 1 over h sub a plus 1 over h sub b plus 1 over h sub c. Hence, this expression is equal to this expression. And we are done. See you in the next article. Bye-bye. Thank you very much.